Hello viewers, I am Kausalya. Today we are going to see the derivation of steady state error when the type of input is parabolic. We know the formula. Steady state error is given by limit s tends to 0 s into r of s divided by 1 plus g of s into h of s. The type of signal is a parabolic signal. So for parabolic signal the value of r of s is 1 by s cube. Now we are going to substitute the value of 1 by s cube in this above expression. So here this is our expression for steady state error, and in the place of r of s I have substituted 1 by s cube. Now this s and 1s will get cancelled and remaining we will be having s square. And the next step is I am moving this, that is 1 by s square divided by 1 plus g of s h of s can be written as 1 by, I am moving this s square to the denominator part. Right. And the next step is I am going to multiply the term. So here s square into 1 becomes s square plus again s square into g of s into h of s. Right. Now I am going to apply the limits here. So when I apply the limit, when s tends to 0, this term reduces to 0, right? So this term reduces to 0 and remaining I am having limit s tends to 0, s square into g of s into h of s, right? So this is our steady state error value. So this term limit s tends to 0, s square into g of s into h of s is replaced by a single term. This is known as Ka. Right, Ka is nothing but acceleration error constant. So the value of Ka is limit s tends to 0, s square into g of s into h of s. Right, and the next thing we are going to find the value of type 0 system. What is the value of steady state error for a type 0 system? So as we all know, this is the basic formula. So limit s tends to 0, s square into g of s into h of s. I am going to apply this expression for type 0 system. What is meant by type 0? Here in the denominator term we won't have an individual s term, right? So here there is no s term present here. So s square and g of s into h of s, the general format of representing this g of s into h of s is k into s plus z1 s plus z2 into s plus z3 divided by s plus p1 s plus p2 into s plus p3. So here when I apply this limit s tends to 0, here this s square term becomes 0. So 0 multiplied by anything becomes 0 here, right? So the value of Ka is 0. When you apply this for steady state error, ESS is equal to 1 by Ka and the value of Ka is 0 here. So 1 divided by 0, which is nothing but infinity. Now we are moving to type 1 system. Again Ka is given by limit s tends to 0, s square into g of s into h of s. So general representation of g of s into h of s is the same thing again. K into s plus z1, s plus z2, s plus z3 divided by s plus p1, s plus p2 and s plus p3. Here we are discussing about type 1 system. So the denominator part should consist of an s with the power 1. Right, this is known as type 1 system. So now this s square and this s get cancelled and finally I am having this s into k into this remaining term, right? S into this part. So when I apply this s tends to 0 here, so again 0 multiplied by this expression becomes 0. So the value of steady state error is 1 by Ka, so which is equal to 1 by 0, which is equal to infinity. So for type 1 system, the value of steady state error is infinity again. Right. Now we are going for type 2 system. So for a type 2 system, again what is the difference here? The denominator term will have s with the power 2. This is known as type 2 system. If there is s with the power 1, it is known as type 1. And again if it is s with the power 3, it is known as type 3. Right. So again the same formula. So s square into k into, for g of s, h of s, everything is same, except here we are adding an s square because it is a type 2 system. So these two terms cancel each other, and when you apply s tends to 0, here what happens? K into 0 plus z1 becomes z1, right? So 0 plus z1 becomes z1, again z2, again z3. Here again we are having k into z1, z2, z3 divided by p1, p2, p3, which is equal to constant. You will be having a number here. So when you apply this for steady state error formula, so ESS is equal to 1 by Ka. So 1 by constant will again give you a constant. For example, 1 by 5 means it will give 0.2, like that. Next we are moving to type 3 system. So when you move for type 3 system, it is given by this formula. Again, limit s tends to 0, s square into g of s, h of s. Again, s square into, the general form of representing g of s and h of s is given by this expression. Here we are dealing with type 3. So here the denominator term should contain s with the power 3, right? So this s square and s cube, they cancel each other, and finally we will be having a individual s term here. So again this expression reduces like this, that is k into s plus z1, s plus z2, s plus z3 whole divided by s into s plus p1, s plus p2 and s plus p3. When you apply s tends to 0, that is when you make s equal to 0, here anything divided by 0, right? In the numerator, what will happen? You will be having k into z1, z2, z3 divided by, for this s it will be 0. So 0 into anything is again 0, and finally anything divided by 0 results in infinity. So for steady state error, it is nothing but 1 by Ka. So 1 by infinity is equal to 0, right? Hope you people understand the video. Thank you.